Holly Samuelson. Holly is an assistant professor at the Harvard GSD, where she teaches courses on computer simulation, daylighting, and environmental technology, as well as consulting with the design studios. Prior to joining GSD, Holly had nearly a decade of professional experience as a licensed architect and sustainable design consultant. Her current research focuses on energy simulation, specifically the challenges involved in reusing design phase energy models post-occupancy. She also enjoys daylighting and hopes that the talents and skills of people in the room will continue to grow up.
Thanks, everyone. Sorry for interrupting the break, but I appreciate it. So the title of my project is Save Shaheen. So first, let me introduce Shaheen. Shaheen is a cashier in our cafeteria at school. I think he knows the names of over 600 students, faculty, and staff, as well as the names of our spouses and what we did last summer. And you're all sworn to secrecy, but the cashiers may or may not sometimes give away free food. So, needless to say, Shaheen is quite beloved in our school. More on that later. So I'm teaching a class that's an elective for 19 students, graduate students. Half of them are research-based and half of them are Masters of Architecture design-based students. And so kind of like math, in my semester, they are learning concepts of daylight and energy simulation and using them both in design. Sorry, wow, this is sensitive. I'm not even touching the button. Okay. So this is a 13-week elective seminar, and like I mentioned, focused on both. So the first half of the semester, they're learning daylight simulation. So they do this primarily through 3 assignments. And so from the lessons learned from the research of Christoph Reinhardt and Diego Ibarra, they've learned that one of the best ways to teach students is to kind of let them do it first, and then figure out what they did wrong, and then have them do it again. So what we did first was, this is a space in our school, and the students had to do a daylight simulation of this space. They were all working on the same space. And then, they got their assignments back and realized how no one got the same answer and what was wrong. And some of the major points were, I purposely picked a space that had this giant overhang. So they were forgetting to model the context around the building. So they learned that. Learned to model the adjacent room with glass, the surrounding ground planes, et cetera, et cetera. So they did this project twice, and then they jumped right in and they did this design project that I'm about to talk about. And this was a 2-week assignment. It was assignment 3 of 7 in the semester. They had 2 weeks to work on it. They worked in groups of 2 or 3. And so the idea was to look at our cafe on site and define the daylight shortcomings. Our restaurant here is called Chow House. It's a nod to the Bauhaus and Walter Gropius. They had to set their own design goals, and then they had to design an intervention for our cafe. And it could have been either a low cost, something that the school might actually build and install, or it could be no holds barred, a major renovation. And they were given a Rhino model of the space to start. So here's an image of Chow House, very glazed, multi-story space. It's on the northeast corner. And you can see that we do have a bit of a glare problem. And I should mention that at this point, the students haven't learned to use the glare tools yet, so they're mostly just looking at the climate-based daylighting metrics. And so I'd just like to talk about a couple of the student groups. So student project 1, I picked kind of an example of each approach. So this was a sort of a major renovation approach. So what they did is they're looking at a section here through our cafeteria, and looking at how much sun penetration there is. And then what they ended up deciding to do was to add on an extra floor as an overhang. And they started from an idea of, hey, an overhang here would be nice, and then realizing, oh, the school would never really add on just this little kind of sticky overhang. But what we also have is a major shortage of space. So what they ended up doing was adding more space for studio desks. And it might sound counterintuitive that on the east side, this overhang would really help, but I'll get to more on that later. So here you can see is the winter sun. This is the before. So this is the after, where they've added on the extra studio space. And here's where they ran some of the simulations. So some of their assumptions, and you can see the initial state in terms of daylight availability. It's pretty much all pink, and then afterwards, they've definitely improved it. And then here's a section, so you can see here's the cafeteria space. And basically, our school has a series of stepped balconies, and that's where all the student studio space is. So they basically added an extra level of balcony at the end. So you can see here's the double height cafeteria space, and here's their mezzanine extension. And so here's the before. And I do actually like this building, but I'm not a big fan of this anyway. To me, at this point, it kind of reminds me of an Arby's or a greenhouse or something. And so here's their after, where they added on an extra bay. And so going back and forth, I do kind of like it. I like their version better than the original, so I was pretty happy with that. So that was the major renovation approach. Student group 2 took the opposite approach and said, hey, let's design something that could actually be built in this space and that we actually might get funding for it. And so what they were looking at is, okay, we have the traditional rule of thumb that most people are taught, okay, on the south you should have horizontal louvers, on the east and west you should have vertical, and how does that really work? So that's where they started from. But I should mention, here's the site. So here's the northeast corner where the cafeteria is, and we do have a lot of context around here. So here's a shading map. And what this group actually figured out too, which was pretty ingenious, was that we have this extra wing. There's kind of like a mini courtyard in here, and there's glass right here. And so they figured out that the glare problem is not just coming from the south or coming from the east, but it's coming from the north. It's being reflected off of this portion of the building. So they figured out that that was something that they needed to address as well. And so this was the before. Sorry, the title's getting cut off. But again, the daylight availability, all pink. Here they're looking at the daylight autonomy and the daylight luminance. I'm sorry, the UDI. So they started off and they said, okay, let's try the traditional vertical fan approach. That's what we were told we're supposed to do. And then, sorry, okay. They also did the horizontal, and then they did a combination of the horizontal and the vertical. And then they decided to get a little creative with the design, and I think this was just design inspiration more than anything. They decided that, okay, we're working with this 9.8 degree tilt. What if we tilt the grid 9.8 degrees? I think it was just some means of inspiration. And so here they have this warped diagrid. And then they figured out that they still, running the numbers each time, and this is kind of their matrix of their design approach. I'm not showing you the whole iterative process. But they kind of figured out that they're still getting too much light. This still isn't working. And so they went to Climate Consultant. And I don't know if you've ever used this, but it's pretty convenient. And you can check out, different angles of overhang. So that's what they're doing here. And they figured, oh, okay, we really would get some benefit from angling our bins. So that's what they ended up doing. They ended up with this warped angle diagrid. And it's still a bit of a problem, but for a 2-week evaluation, they were able to improve the metrics. And here you can see that was their final design. So the average daylight availability was before it was 6%, after it was 31%. The useful daylight luminance improved from 33% to 62%. And here's what it looked like. Now, one could argue that, well, it might have been better to put this on the outside of the glass, but the thinking was that this is a historic structure. We didn't really think that Harvard University would approve of doing anything to the outside, and if we were going to build this in our wood shop in the basement at a low cost, that probably having something that didn't need to be weather resistant would be the best approach. So that's why it's going on the inside of the glass. As it turned out, these were all seniors, and well, they're all master's students, but they were all in their ultimate year. So we never did end up building it because they got too busy with thesis, but maybe someday we'll try to apply it. So the students had a lot of fun with this. Here was one poster, Saving Private Shaheen. There were about 7 different student groups, and the one thing that shocked me and made me very happy is that all 7 approaches were completely different. Here's one where they had these twisting louvers. So you can see here the no louver approach, and then with their louvers, they were meant to be operable. Someone got the great idea. They also did another project, but then at the end they said, hey, what if we just put a tree up here? And it was kind of tongue-in-cheek that this tree probably outperformed all of them. Someone else had kind of an opening garage door kind of scissored louver effect, and they got pretty into trying to use some of the dynamic tools and model at different times of different seasons to figure out what degree of openness we would have. Another group kind of, without knowing about Shaderade, kind of developed their own Shaderade-like tool, which was really exciting. And then their design implementation though was the cloud. But they figured out exactly where the cloud would need to be more dense and less dense. But it was kind of lacking in its design realism a little bit. So the title on this one is, Did We Save Shaheen? So that was just the title. I thought it was funny. I wasn't actually trying to save Shaheen, to be perfectly honest. But I had this idea that I really liked with student projects, and we have this digital bulletin board in the cafeteria, which always has the same thing on it for like 6 months. So I said, hey, what if we made posters of each of the student projects and just put them rotating on a slideshow in the bulletin board? So we did that, and then the next thing you know, Building Services rearranged Chow House. So I don't know that we had anything to do with that. It might have been a coincidence. But the interesting thing was they took the cash. So part of the problem is that other people, they can choose where they want to sit. It's pretty crowded, so they only have some extent of choice. But the poor cashiers are just stuck here, and they just fry all morning long. So one thing that the management did was, without consulting us, they moved the cashiers from here over to this end of the cafeteria, which if you look at the simulation results, you realize it's only marginally better. It's not really the best approach, but they're trying to solve apparently two problems. So one was the daylighting problem, and the other one was apparently there's a decent amount of food that goes missing from the cafeteria. So they thought that if they let the cashiers keep an eye on the whole cafeteria and stood between the food and the exit, that they would stop that problem. So we'll see how that works out. So we moved from there to there. Okay, so that was, I'm going to keep going. I have one more project to show. Thanks. That was project number 3. And then here I'll talk about project number 7, which was, this was their final project. So they learned some thermal simulation using Design Builder Energy Plus. And then in the end, they had to design a camp for 4-H students on Long Island. And so here's the site. I thought that this is a real project. It's a nonprofit client of one of my colleagues, and they're trying to, as you can see, it's near the shore. And so the interesting thing I thought about this project was all of the views are to the north. And the client is interested in having an educational building and interested in some degree of net zero, although I'm not sure that exactly what he wants there. But so I thought that was an interesting project. So here, I'm skipping over most of the thermal parts since this is NEMA Day, and I'm just going to talk about some of the daylighting approaches that the students took. So I'm just seeing how I'm doing in time. So here they were basically looking at their different roof geometries, pretty straightforward, using the simulation to help design the clear story, looking at here with no shading devices. So the interesting thing was that we do have this, I think this is actually upside down. So this is this is to the south. So looking at a movable wall, here's a screen shading device. Here's another student group, so they were using the radiation map to try to size their solar hot water heating. I should mention that I shot myself in the foot a little bit with this project because I kept adding different layers to it. So at first I got very excited, okay, here's this net zero energy project, that sounds great. This camp, how much more fun can you get than a camp for kids? Everyone loves camp. But then I realized that it's an assembly space, so it's a dining hall / cafeteria. It has a commercial kitchen. It's mainly occupied in the summer. And I tried to get the students to be very rigorous about the internal loads. So we were really looking at commercial kitchens and assembly spaces and how many loads would be in there. And I realized that even though we're in New York, I suddenly created really cooling-dominated building. So it became very much about natural ventilation, and I'm not sure that I had time to really cover that as fully as I would have wanted to with these tools and in this semester. So that's something I'm going to do differently next time. Here was another student project where they were using these light tubes, and hopefully they used enough ambient balances to really, and divisions and everything to get the approach to work. But here you can see before and after. Here's their assembly space. They had one occupiable area above, and then the tubes were bringing some amount of light to the area below. There was the assembly space for the students to gather and for eating, and then below was cooking and an apartment, etc. And so since I have time, I'll just mention the one other interesting project that we did in between these two. Came from a conversation I had last year at D-Day with Johnny. And he said, you know what would be more fun than using simulation, always try to make the best building? Let's try to make the worst possible building. I thought, yeah, that really makes you stop and think. So one of the projects that we did was each student group ended up with a different climate, and they were kind of in a head-to-head competition between two groups. And so they had to design the best performing building that they possibly could, energy-wise, and then the worst possible building that they possibly could. And they had rules so that they had to fall within the constraints. And then the delta between the two, whatever the energy difference was between your best performing building and your worst performing building, you were trying to make that as big as you possibly could. And then the team that had the higher delta, they would be the winners. And I actually found that, yeah, when you're not relying on rules of thumb anymore. And when you're trying to break the system, you really have to think about it. Okay, well, within reason, what if I made the ceiling heights 10 meters high or something like that? Maybe I should make it all glass and make all my glass facing in one direction or another. And so I found that that was really a great learning tool. And that conversely, sometimes someone asked a question earlier, which was, what concepts do the students not get? And I was finding the things that they were not getting were things where more was not always better. So just adding insulation was not getting them anywhere. Where that was their instinct, was to just keep adding more and more insulation. Here in Mexico City. So, so I think that that competition was one of the interesting projects. So thanks for giving me that idea, Johnny. and that's it. Thanks. Any questions?
You don't have any examples of this delta, best and worst.
I should have. I went so much faster that I probably should have put them in the deck, and I apologize for they're on my own computer.
Is that copyrighted?
Pardon?
Is that copyrighted now?
No, feel free.
How do you manage that time-wise, Holly? I mean, I take twice the time. I take two classes, one for lighting and for thermal. So.
Well, that's why I asked Max the same
what do
question.
you skip on? I mean, or what do you do, because you know the other classes?
Right.
What do you think you do more than that?
Well, I should admit that next year it's going to be 1.5 classes because I do think it was too quick.
Yeah.
So that's why I asked Max the same question, because it is so much to squeeze in. And so thankfully, this was asked of me by the administration, but it works out well. They asked me to make daylighting a separate half-semester class. So I think that's going to give me a little more time to go over the fundamentals, which I think I assumed that the students knew more than they did. So that'll be helpful. And let's see, in daylighting, and also, we did not go too much over glare, because I do think that, honestly, I find it personally hard to design with. I think it's easier to check a design once I have it, but because the class is based on, it was a design class, that was one thing that we skipped a little bit. We weren't going too much into existing buildings or calibration or anything like that, which hopefully now we'll have more time to get into.
Where are you going to go from here? What's the direction or the goal? Yeah.
That's a really good question. A lot of my goal in the design class is to give the students the resources then to get out of their way. So this is only my second semester teaching, so I'm really trying to get everything set up the first time, and then I think I'll have more chance to refine it.
Just giving them a tool, and then then they know what they're doing, and then let them design. So that's sort of the
Yeah. Any other questions?
I noticed, I missed, I have to step out, but in some of the projects, it looks like you use a lot of existing buildings and sort of working on existing buildings. Were there any instances where you're doing totally asking students to work from sort of nothing? You had to have a site, and then was that one of the...
Yeah, I should have clarified, sorry. The daylighting project was an existing shading retrofit, and then this camp is actually a new building.
Oh,
so the client had already decided that they're tearing down their old dining hall. This is a brand new building.
So the students could come up with their own design for the building.
Yeah.
And was that design completely part of your class as well?
Right.
So they designed a full building in your class.
Right. Right. And it was a pretty simple program, to be honest. And two things. One thing that made me very happy, there's a culture in my school where there's some designers that were worried that sustainable considerations lead to cookie cutter design. And so that if we think about energy and daylighting, that we're all going to have long boxes with south-facing light shelves. And so I was very happy with the first project that they were all wildly different. I mean, I didn't even think that there could be 7 such wildly different approaches. And then the second project, they all came closer to the center. They were mostly long boxes. Here it's angled more for view than thermal reasons. And so it's interesting. I'd like to pick something where I'm hoping that maybe the results will end up being more varied next year.
But do you know that that's directly a result of simulation? The shape of the building? I mean, it could have been for other reasons, right?
Mm-hmm. Mm-hmm. So anyway, I would like to find that out. I guess one thing I'm interested in is how can we use simulation as a design tool, and ideally it would not lead to cookie cutter design, which I don't believe it does. So I'd like to work more on proving that, I guess. So. Any other questions?
Thanks, Holly.
Thanks so much.